Ladies and gentlemen, welcome back to another Backwoods Solar YouTube video. In today's YouTube video, we'll be talking about the basics of batteries and battery wiring. Stay tuned. Starting out first today, we're going to talk about the electrical characteristics of batteries and how to interpret what your data sheet or label on your battery means. First variable we'll talk about, or statistic we'll talk about, is voltage of batteries. You can see over here on most batteries, the nominal voltage here will be listed. Nominal voltage is just a general characteristic of where that battery sits. That does not necessarily define the operating voltage of that battery. Nominally, you'll find batteries, whether they're lead, lithium, sodium, can be found in 2 volt, 6 volt, 12 volt, and then 24 and 48 volt very commonly. And then they can be used in combination, wired in certain combinations, depending on the overall voltage you're looking for. The second figure most commonly found on batteries is a capacity or amp hour number. Amp hours is a rating of amps over time. So using this, taking out efficiencies, a 100 amp hour battery as an example could support a 100 amp load for an hour or a 1 amp load for 100 hours as an example. Of course, in real world, especially with lead style batteries, we have some additional efficiencies, but that's a general way of thinking about amp hours and capacity. The last number you'll generally encounter is a watt hour number, or watts. Watts is a true measure of power. It's a volts times amps scenario. So watts is universal. It doesn't matter if we're dealing with AC or DC in this case. But watts or watt hours or watts over time is probably the most accurate way of measuring a capacity within a battery bank or within a system. Besides the stats of each battery individually, the next important thing to consider when setting up your battery bank is the way that the batteries are wired, or in what configuration they're wired. This really relates to two different ways of wiring batteries together, and this includes a parallel wiring, like you see here, where we're connecting positive to positive. Granted, these are exaggerated just for the video here, but we're connecting positive to positive, negative to negative on these two batteries. And you'll see here we have our main negative leaving and our main positive leaving here. Now, this is exceedingly important in any battery configuration, whether you're doing a parallel wiring configuration like this or you're doing a series configuration. You always want to leave from the opposite corners of the string or the bank. This ensures we get equal flow of energy out of all batteries within that string or within that bank. If we tend to land our main system connections off of our primary battery, we tend to get uneven utilization, or there's unequal work done throughout the bank in terms of energy in, energy out. So one of the most important things when wiring, besides the overall configuration, is making sure we leave opposite corners, as you see here in this small demo. In our example here with these two 12 volt 35 amp hour batteries, when wired in a parallel configuration like this, we maintain the 12 volt overall nominal voltage, but we add to the amps or the capacity of this bank. So now wired like this in parallel, we have a 12 volt bank at 70 amp hours. Again, each of these are 35 amp hours. So this gives us an overall bank of 70 amp hours at 12 volts. Now, as you can see here, wired in this series configuration where we're wiring positive to negative across the bank, we now have these same two batteries wired in a 24 volt configuration, but still maintaining 35 amp hours overall. So we're doubling the voltage in the series configuration, or adding to the voltage and maintaining the amps or the capacity. Now, it is important to mention, regardless of the way that these two batteries are wired, whether they're wired like this in series or like previously wired in parallel, we still have the overall same amount of usable power out of this battery bank as a whole, whether it's wired in parallel or series. And doing the math really quick, again, volts times amps, because volts and amps do the same amount of work when we're calculating watts or watt hours, If we have half the capacity but double the volts, we have the same amount of usable versus the opposite of that equation as well. When wiring your bank into the chosen configuration, it is exceedingly important, and especially with lithium chemistries, that we be mindful of our cable lengths and our diameters. And again, especially with lithium, we maintain equal cable lengths and equal cable diameters as much as possible to each battery or group of batteries. The reason it's so exceedingly important with lithium or sodium is that they have low resistance internally. So any slight differences in external resistance, cable length, diameter, corrosion, may cause favoritism throughout the group or strings of batteries to occur, where the batteries or battery with lower resistance may do more work, more total energy in and out over time. So especially with lithium, it's really important to make sure we have cable length, equal cable lengths and diameter, as well as utilizing preferably a bus bar like the Lynx Bus Bar system to ensure equal resistance to each string or group of batteries. With lead acid, we have a little bit more leeway with that as they're not as low resistance, so slight differences in resistance between strings or batteries isn't as noticeable as it would be with lithium, but still good wiring practice to have equal lengths and equal diameters. When selecting a battery or designing a bank for your application, I do want to make one small note about lithium and sodium batteries. It is really our preference here when purchasing lithium or sodium that you do purchase them and utilize them at their design voltage. While a lot of manufacturers do allow, as an example, 12-volt batteries to be put in series in terms of lithium or sodium, I think that takes away one of the biggest advantages of lithium and sodium, especially at higher voltage banks like 24 and 48 volt, is that each battery is at system voltage. So you only need one lithium or sodium battery to keep the system functioning. So when you put them in series and you have a battery drop out in lead or lithium, the entire voltage of that string or bank or overall voltage of the system will drop, usually below where the inverter can operate or the other supporting components in the system will operate. So getting your lithium or sodium at system voltage and wiring them in parallel, I think gives you a lot of redundancy and ability to resolve issues. If you do have a problem with one battery, it can be easily isolated and removed while still allowing full system function. If you do have a circumstance where seriesing lithium batteries makes sense, or maybe you already have them and you're increasing the voltage of your overall system, I would certainly recommend when seriesing lithium that each series string of lithium is brought up individually to a bus bar like the Lynx Bus Bar system. And then even on top of that, if you have multiple strings, to use a battery balancer like the Victron battery balancer that can handle or accommodate for variations in your strings of batteries and balance those out. We tend to see some issues, especially in winter or with heated lithium batteries when they're run in series in large banks. We tend to get some imbalance problems, either string to string or battery to battery occurring. So using a bus bar and specifically a battery balancer helps alleviate a lot of those issues. Once installed and operational, it's exceedingly important that you follow what the manufacturer recommends both for charging and maintenance of your batteries. In the case of lithium or sodium batteries, there's not much day-to-day maintenance that needs to be done. In the case of lead acid batteries, especially flooded lead acid, they definitely have some more day-to-day or week-to-week maintenance that you have to be aware of. We do have a lead battery maintenance booklet, battery booklet, that I'll link in the description that gives a general primer of lead battery maintenance and care. But generally, we recommend defaulting to exactly what the manufacturer recommends for voltages and maintenance. Beyond the specific recommendations as noted by the manufacturers, I just want to mention a couple general recommendations for your battery bank and long-term health. Number one, on both lead and lithium batteries, I think it's important after some time period, month, couple weeks, month, couple months, to come back and recheck our connections for tightness. This is important, again, especially with lithium, given the low internal resistance. We want to make sure all our connection points are as equal resistance and tightness as we can. And then the second note specific to lead batteries is, and flooded lead acid in particular, is if we're developing any corrosion on our terminals and how to deal with that. You'll see a lot of discussion about removing that corrosion or those crystal buildup. I'm not a big fan of using baking soda or any really alkaline other chemicals on my batteries. I think it's best and just as effective to use really hot water to melt away any of that corrosion or crystal buildup. That way, in case any of that water gets into the battery, it's not going to cause any issues with the pH internally, like if we had a little bit of baking soda sneak inside that battery. So again, it's just as effective on dissolving that crystal buildup on the terminals. So again, I would just recommend using hot water to do that. The last thing we'll talk about today relative to battery health and maintenance is knowing when to charge or how to charge your battery in particular. This is where I believe, in terms of battery capacity, using a dedicated battery meter like a Victron Smart Shunt or BMV712, which we have videos on both of those here on the YouTube channel if you needed more information, are very, very helpful day to day. And I would say in a lot of cases with lithium or sodium, almost a requirement, in particular with lithium iron phosphate chemistries, due to the fact that lithium iron's discharge voltage characteristics remain exceedingly flat throughout most of its discharge cycle. So it becomes very difficult as the end user to determine based on voltage alone what capacity your battery bank is at. This is where these meters constantly measuring amp hours in, amp hours out, provide a very accurate measure once calibrated of battery bank capacity and overall health. Using a battery meter like the BMV712 just gives us an easy at-a-glance gas gauge, regardless of battery type, to get a good understanding of our capacity. Instead of having to use voltage or some kind of voltage table to cross-reference voltage and capacity, the battery meters just give us a clean, understandable data point.
Backwoods Solar is America's oldest and most trusted solar retailer with nearly 50 years of experience. Head over to our website, backwoodssolar.com, to get a free copy of our planning guide. While you're there, check out our Learning Center with articles on setup, sizing, tax credits, and so much more helpful information, especially if you're just getting started with solar. There are also links provided in the description.